Hello, I'm MannySoto and I love math, and I want to show you how to check if your answer is correct by using by solving a quadratic equation and and then checking to see if we got the correct answer. So let's begin with writing down the formula for the quadratic formula. I write it on this side. Okay, so the quadratic formula is 4ax squared plus bx plus c equals 0. Then x equals negative b plus or minus the square root of b squared minus 4ac. And let's extend this radical so that it covers the c part. And all of this divided by 2a. Okay? The discriminant is what's inside the radical. We'll call it d. And that is b squared minus 4ac. So the first step of using this thing is identifying your a, b, and c. A is the number in front of the x squared, b is the number in front of the x, and c is the number without an x. So we put, let me get a different pen so that we could see the part that is not formula. Let's get how about a fancy color pen? So we're going to say A equals, and then we're going to say B equals, and then we're going to say C equals. And our A is always in front of the x squared, and our B is always in front of the x, and our C never has an x next to it. Please excuse the technical difficulties with this weird program. Okay, so now our A is a 2, our B is an 8, and our C is a 5. So let's start by computing the discriminant. This guy here. It makes it easier than doing the whole quadratic formula at once. And we can see from the beginning if we're going to get a real or an imaginary solution. So we have the discriminant equals, we'll leave parentheses for the b, and we'll leave the squared, minus the 4, and we'll leave a slot here for the a and one for the c, parentheses of course. So our b is an 8, and our what is, okay, a is a 1, and our c is a 5. 8 squared is 64, minus, and this item here is 20. And we get, what is this thing? 64 minus 20 is 44. Okay, so now we can use the quadratic formula now. Let me get a different color for the quadratic formula. Let's go with the green. Okay, so our x is equal to negative b, and it's going to be I made a mistake here. I should have put parentheses because we already wrote it. Let me erase that b. Okay. And now I'll go back to get my green pen. And we have negative b. And then we have plus or minus the square root. And remember we computed all this stuff here with this 44. So let's just put it in there. We know what our 44. And then divided by 2a. Our a is 1 and our b is 8. So then we have negative 8 plus or minus. Let's do a shortcut here. This is 44 times 11, right? That's 44. And we can assign each one their own radical because it's a times. And we divide this by 2. And we're left with negative 8. And then we have plus or minus. The square root of 4 is 2. And 11 does not have a square root. So we just leave it like that. All of this divided by 2. Let's do a reverse distribution. And we're left with negative 4 plus or minus 2 divided by 2 is 1. The square root of 11. Okay? So here, let's write the solutions with a different color. How about a blue? Let's write our solution set that we derive right now. And x is equal to, let's write the positive one first. And what I mean by writing the positive one is taking all this thing, but pretending that this negative is not there. And that's how you write the positive solution. There's going to be 2, one for the positive and one for the negative. So we get our negative 4. And it's plus square root of 11. I put the negative one first. Oh, no. I put the positive, I'm sorry. The negative 4. And now we use a negative. Minus the square root of 11. I should use the curly bracket. Anyway, so now we're wondering, like, how do we know that this thing is right? So let's test each solution. Let's begin with testing this guy. We'll put add x equals negative 4 plus the square root of 11. Okay? Let's underline it so we could say that we're doing this. Now we take our original equation that we solved. We take this guy here. And we substitute x into each of the x's. And at the end we should get both sides of the equation should be identical. So I'm going to write 2. And I'm going to leave some parentheses. That's where my x went. Plus 8. Plus 5. All this equals 0. Okay. So now let's put our negative 4 plus square root of 11. Negative 4 plus square root of 11. So let's use some distributive now. We can't do the 2 yet because this item here has an exponent. So we got to multiply it out. Like, we got to do the exponential operation first, which is minus 4 plus square root of 11 times itself, minus 4 plus square root of 11. And this we can distribute. It goes to that guy, then that guy. So positive times negative is negative 8 times 4 is negative 32. And plus 8 square root of 11. And then we put our plus 5. And all this equals to 0. And now I would say that the easiest thing to do here is to multiply this out. So it's gonna get a little, I wouldn't say nasty, it's an easy operation. So we'll do a 2, and then we get negative to negative positive 16, and minus 4 square root of 11. The same thing again, minus 4 square root of 11. And then you have a square root of 11 times square root of 11 is just 11. And then I guess we can combine the 32 and the 5. So negative 32 plus 5 is negative 27. Plus, I forgot the 8. 8 square root of 11 equals 0. I'm running out of space on the right side, so I'm trying to, please bear with me. Let's add what's inside the parentheses here first so we can make it easier for the next step. 2, 16 plus minus 4 square root of 11 minus 4 square root of 11 is minus 8 square root of 11. And then here we put our, I could have added these two, plus 16 plus 11. I could have put a 27, but I'll just bring it down to keep it clear. Nothing wrong with doing an extra step. And we'll bring down the minus 27 plus 8 square root of 11. I can see that that's going to equal 0 now, but well, I think it is. Let me continue. So we have 2, and then we have 16 plus 11 is 27, minus 8 square root of 11, minus 27, plus 8 square root of 11 equals 0. And I'm left with an extra 2. I'm left with an extra 2 because if you notice, where did I make the mistake? Notice that this here inside, is the same as that. But I have a leftover 2, which is here. And where did I make the mistake? Well, the mistake is identifying my A. Let me put a circle around it. That's the A. That's the A in the formula, and that's the A. And then there's the A. But notice that this here, it looks like a 1. To me, it looked like a 1. No excuses here. But that should have been a 2. And it seems that everywhere, oh no. Yeah. Everywhere where there was supposed to put a 2, I was consistent in putting a 1. So we left this perfect. Anyways, no worries. Let's get the real solution. What I'm gonna do is I'm gonna do it again because I made a mistake. But you won't have to suffer through it. You at least you saw how checking. You check it in there if you get the right answer, and this shows that this is valid for checking an answer. So I'll do it on a subsequent video so that you could go through this again and verify for yourself that it is correct. But I'll post you a video shortly on that.